Welcome to This Explainer. Today, we're tracking a trillion-dollar sprint to build the world's first true artificial intelligence. It's a race that started with ancient myths of mechanical beings, but has rapidly evolved into an engineering reality that is aggressively reshaping our global economy. Let's dive right in.
For most of human history, this question was pure science fiction. Then came the computer. Suddenly, intelligence wasn't just some biological mystery anymore, it was an information problem. And once intelligence could be represented as information, scientists started asking a radically different question. Could a machine be programmed to reproduce some of the things we call thinking? That profound shift turned a philosophical mystery into an engineering problem, and it fired the starting pistol on the massive race we're still running today.
Section 1. The Quest for Intelligence, from Ancient Myths to the Starting Line. To find the true starting line to this race, we really have to go back to a time when computers were unbelievably primitive by today's standards. The race officially kicked off in 1956 at Dartmouth College. Fun fact about this, those pioneers were so wildly optimistic, they thought they could simulate human intelligence in a 2-month summer project with just 10 people. No way, right? As history showed us, getting from that 1956 proposal to the massive breakthroughs of 2012 and 2017 was a grueling, multi-decade marathon of sputtering starts.
Section 2. The AI Winters, when enthusiasm collided with reality.
So, early systems were completely trapped in these rigid, if-then logic architectures. Sure, they dominated in highly controlled narrow environments like chessboards, but the real world is messy. It's built on ambiguity, context, and incomplete data, variables that easily broke those brittle, early rule-based frameworks. The methods simply didn't scale when the environment introduced even the slightest unpredictability.
By the 1970s, the hype train completely derailed. Basic human traits like vision or natural language processing proved impossibly hard for those early architectures. Funding evaporated, research stalled, and the industry entered a deep freeze known as the AI Winters. Decades of disappointment followed, with many experts wondering if the dream was just entirely dead.
Section 3. The Neural Breakthroughs, Learning Patterns from Data.
But you know, the field didn't just disappear. The ultimate aha moment came when researchers finally stopped trying to manually program rules and started letting machines find the patterns themselves. Neural networks, which are loosely inspired by biological brains, adjusted their own internal weights based on massive amounts of examples. It was an absolutely brilliant paradigm shift. But for years, this beautiful math was stranded, just waiting for the hardware to catch up.
So what changed? Well, the digital explosion. Suddenly, the internet and enterprise businesses were generating data at unprecedented scales, and at the exact same time, graphics processors became dramatically more powerful. The digital explosion provided the raw fuel, and massive cloud computing provided the engine. The environment was finally primed.
The results were literally explosive. In 2012, a neural network called AlexNet shattered expectations in image recognition, proving the sheer power of deep neural networks. Then, 2017 changed everything. Google researchers and their collaborators introduced the transformer architecture, proving that attention was all we needed to crack complex sequence processing. This laid the absolute groundwork for the massive modern language models we use today.
By scaling these models up to hundreds of billions of parameters, the behavior became almost magical. Machines were no longer just crunching numbers. They were writing essays, translating languages, generating complex computer code, and even passing standardized tests. The definition of what a computer could do changed overnight as generative AI moved directly from research labs into our everyday lives and businesses.
Section 4. The Pursuit of AGI, Moving the Finish Line.
As billions poured into the industry, a new question emerged for all of us. What comes next? The new finish line is artificial general intelligence, or AGI. It's no longer about narrow parlor tricks. AGI broadly means an AI capable of performing virtually any economically valuable intellectual task at or above a human level. It wouldn't be limited to narrow applications, it would be broadly, genuinely intelligent. The whole shebang.
Now, the absolutely crucial point here is that raw capability is not general intelligence. Today's models can write complex Python scripts in seconds, but they will still confidently tell you to put glue on your pizza to keep the cheese from sliding off. They can generate convincing text, sure, but they often lack actual reasoning or robust world models. This is exactly why researchers are urgently exploring beyond just making models bigger. They are hyper-focused on reasoning, memory, tool use, and reliability. Section 5. The infrastructure competition. Grounding software and hardware.
Getting to AGI isn't just a software problem anymore, right? It is heavy industry. Tech giants are waging war over top talent, hoarding advanced semiconductor chips, and building data centers so massive they literally require the power output of small cities. It's a staggering infrastructure race demanding historic amounts of energy, cooling, and capital.
And because this physical infrastructure is so strategic, governments are essentially treating it like the new space race. They're pouring billions into AI research and infrastructure. The nation that achieves AGI first effectively secures a generational advantage in national defense, economic productivity, and scientific discovery. Leading the AI race is viewed as leading the future of global power.
Section 6. A new civilization layer, the economic and societal implications.
We don't even need to reach AGI for this technology to completely redesign our world. But this level of transformative power brings immense friction. We aren't just talking about shifting software paradigms, we're looking at the rapid devaluation of hard-earned human skills and the potential disappearance of certain jobs. There's an unprecedented concentration of power among a few tech monopolies, and a regulatory landscape that is desperately trying to catch up to the math.
Ultimately, this race to build AI is a fierce competition over the future structure of the global economy itself. What makes this era so wild to live through is the sheer uncertainty of it all. There's no map here. No one knows exactly when AGI will arrive, or if the current architectures will just hit a wall. Yet the economic prize is so unfathomably large that companies are betting the house just for the chance to cross that finish line.
If humanity succeeds, it won't just be a new product. We're talking about a new layer of civilization. We've built machines capable of producing behavior that once seemed exclusively human. Future historians won't just look back at this era and say, oh, computers got faster. They will mark this exact period as the moment intelligence itself became an engineering problem.
Which brings us right back to our original question. Can a machine actually think? Whether it's true cognition or just brilliant computation might not even matter in the end. The real question is, what happens to human civilization the day after we finally win the race? Thank you for joining me for this explainer, and keep questioning what comes next.